that we have to think about it. Understanding things that can go wrong in a database, and a distributed database in particular, is really kind of what we're going to talk about today. And in Cockroach, and I think, some of these, like I said, I think in every webinar we do, and all of these live streams, some of the concepts we cover here definitely apply to just our normal code and the way that we think about things. So a little bit of housekeeping before we get started. Yes, the recording will be available after the event. Please do ask questions in the QA panel, engage in chat. I'll be in both the QA and the chat along the way, and trying to, either answer or bring the questions live as we're talking here. This is a bit more of a free form conversation. So we would love for you to be a part of it and to participate along the way. So today's session is, I would say it's actually a little bit more beginner than intermediate. People ask us all the time to kind of call out what that's going to be at the beginning, and that's what we think. So some of the things we're going to cover is, what are the things that can go wrong with the database and how do you identify them? I definitely will definitely pull together a little bit of a spin on, the distributed concept of a database, oh boy, like latency and network connections actually have a big issue sometimes when you're dealing with transactions in globally distributed regions of a database, right? So how do you investigate that? What are the tools that we provide in Cockroach? And then I definitely want to talk to my friend Piyush here a little bit more about observability and OpenTelemetry and these sort of things. So Piyush, do you want to join me here? I'm gonna actually let's just both come on video here. Hey buddy, how are you today?
I'm doing well, Jim. How are you?
Cool. Everybody, I'm joined by Piyush Singh, who's our group product manager for all things observability. Piyush, you've had a growing set of responsibilities over the past couple months, including like a new human. So congratulations on that, buddy. But I think like a couple of product areas too, right? Like what all do you manage here at Cockroach Labs?
Yeah, I focus on everything that, really an operator would handle when it comes to CockroachDB, right? So like someone who's responsible for, someone in your typical like DevOps or SRE role, someone who's responsible for keeping the database healthy while your actual like application developers, actually use the database for your application, right? So the operational aspects of the database that I cover are things like observability, absolutely. There's also, security. There's the actual deploying of the database, right? So how you actually spin it up, deploying on top of Kubernetes. So things like our Helm chart, our Kubernetes operator, but then also other aspects of deploying the database, like version upgrades and decommissioning nodes and all that kind of stuff. So it's like the full gamut of all the operational tasks you can do in a Cockroach cluster.
Right. So that's a large swatch of area, Piyush. I know you're pretty busy. You have a great team though, working on kind of all the different things that we have to do. And I think, what's interesting is that's just in a normal database. Doing these things in distributed, as I said before, adds a wholly other level of complexity to these things. So, let's just start at the top. What can go wrong? When you think about like the issues that can go wrong in a database, like how do you kind of categorize them? Let's just start there and we'll use that as kind of a context for the rest of the conversation.
Sure. So I would say there's different layers, right? So when you're first setting up your database, you're making lots of decisions about how you're actually deploying it, right? Is it going to be multiple regions? Is it going to be single? Is it going to be bare metal? Is it going to be Kubernetes? And along with that come, a lot of problems that you can run into, right? So when you're first setting up your environment and configuring it, you might have networking issues. When you actually, figure out how what VMs you want to have running your Cockroach cluster, you get into a sizing exercise, right? So how can I make sure the hardware that I'm actually running Cockroach on top of is appropriate for my use case? And then beyond that, there's obviously all of the components inside the database itself, right? So environment, you've got hardware, then you've got schema design, right? So especially in a multi-region setup, you have to be really careful at thinking about how you structure the logical data inside of your database. Think really carefully about how you're designing the schema, and then obviously queries on top of that, right? So how are you actually manipulating the data? How are you actually accessing, storing, retrieving the data, and is it done in an efficient way? And so we actually give you tools to kind of step through each of those, right? To troubleshoot any problems you might encounter in any of those distinct layers.
Right. So let's just start with database and provisioning as something that I talked about at the top of the hour is kind of like, yeah, network speeds and that sort of thing. I mean, what are the challenges there? And I think we have some tooling around that as well, right, Piyush?
We do. And I can actually share what that looks like. Um, so let me see if I can share my screen here. While that's going, I can talk a little bit about it. So, one of the big challenges that we encounter are especially our customers encounter when they're setting up Cockroach is deploying, Cockroach in a multi-region setup. What does that actually mean? Well, public clouds will have VMs hosted in different regions all across the world, and they'll have multiple availability zones inside of each region. So how are you actually structuring the physical nodes in your cluster across these regions and across these availability zones? The decisions that you make there are going to have impacts on both performance and then the survivability of your data. And there's a trade-off between the two of them, right? And naively, what Cockroach does is it tries to keep your data, it tries to make it as survivable as possible. But that's not always what you necessarily want, right? The way Cockroach does that is it actually tries to spread your data out as much as possible. So, if you're running in, let's say, 3 regions, right, we might keep 1 copy. If your data is replicated 3 times, like it is by default, we'll keep 1 copy of your data in each region, right? That way, if you have a regional failure, right, AWS has an issue and the East Coast goes down or something like that, your database will still be up and running. You'll still have a copy of your data safe and sound. Now, the tricky piece is that can cause performance issues if you're distributing Cockroach across the entire world, right? We have customers who are running, nodes in Australia, nodes in Europe, nodes on the west coast of the US, right? And it's all a single logical database. What you don't want to do is get into a situation where you have, pieces of data scattered across the entire world, and then you do something like something that triggers a full table scan, let's say, right? And you're suddenly scanning all of this data from multiple locations across the entire world, and there's hundreds of milliseconds of latency between each of these different data centers, and adding, joining all this data up, aggregating it, and performing computations on it suddenly becomes extremely expensive compared to let's say a single region database or a more traditional database like Postgres, MySQL, Oracle, SQL, or something like that. So we actually give you tools to kind of help visualize this stuff. And so the network latency page in our UI is actually a good way to visualize that.
And this is really something that's unique to us and being distributed. I mean, this comes back to this whole concept of, I think people, when they typically think of a database, think of the logical model. You have to think of the physical model of the data as well. What you want to survive, how fast you want data to get to people. And if you start thinking about the physicality of nature, there's Piyush, you've heard me say this before, the ultimate competitor of Cockroach is the speed of light. Well, sometimes the speed of light isn't always the speed of light through the fiber, and there's other hops and issues, and that kind of helps us kind of identify where these things happen, right?
Exactly. And you can think about it, I guess, getting into the architecture of Cockroach a little bit to explain why this happens, right? So by default, Cockroach is replicating your data. And again, right, the idea is we want to make it as survivable as possible. Now, we do several optimizations to kind of coordinate how we're handling updates to these replicas of your data, right? That's kind of the magic of Cockroach. You're kind of treating it as a single logical database, but behind the scenes, we're like replicating and distributing all this data. But hopefully you don't have to be aware of it. Now, you kind of do have to be aware of it when it comes to multi-region setups. And the reason is, if you have 3 copies of your data, we'll designate one of those copies. Essentially, it's what we call the leaseholder. And that's the copy that's coordinating reads and writes for that particular piece of data. Let's say it's a specific row in a table. So if you make an update to that row, right, and you have these multiple copies of data scattered across the entire world, your application will connect to your database. You'll, let's say, make an update to that row. The database will route it to the leaseholder. Now, what the leaseholder needs to do is it needs to say, hey, I'll commit this change once essentially 2 out of 3 replicas, right, a quorum of replicas, have actually been updated, and I've confirmed that they've written that change. So if the leaseholder is communicating several hundred milliseconds out to, let's say, the nearest replicas in Australia or something from the US West Coast, that suddenly means an update a point update of a single row can suddenly take hundreds of milliseconds, which is kind of unacceptable to a lot of our customers, right? They're coming from these, single region databases where that should take a couple of milliseconds. Now, what you can do, Cockroach gives you the facilities to kind of constrain the geographic locations of your data and keep them close to each other. And that's, obviously dramatically beneficial for performance, right? So if I have, let's say, users in the EU, in the US, and Australia, I might want to constrain those users' data to those specific geographies, and that'll give those users really snappy performance. But what I can do is architect my application in kind of the same way across all these regions and have like a single logical database while still getting that really snappy performance. Now, of course, the trade-off that you're making here is you're trading off survivability, right? If the data is more distributed, you'll be able to survive a regional failure. If you constrain all of your data to a single region to make it really snappy for people in that region, then if that region goes down, you're going to have data unavailability. So that's kind of the fundamental trade-off there.
So yeah, Piyush, like the complexity and the knobs and the dials are intense, right? Like there's lots of things you can do. Just show us in the UI kind of the network performance thing. Let's just show people. It's really kind of readily apparent once you start to see this, right?
Definitely.
Because data can live on any one of these nodes. Did you have did you have a cluster up and running? Sorry, but
I did, and now of course I didn't.
Well, that's what happens.
Sacrifice the demo gods. Yeah, it's just
right. Exactly. Yeah. So I mean, let
me try to kill this, and I'll restart it, and we'll come back to it. Maybe.
Yeah. Are you just running Cockroach demo, Piyush?
Yes.
Yeah.
So the really cool thing is, and I'd love to explain this to the audience, is Cockroach actually has a way of demoing a lot of our functionality. And there's a command, just cockroach demo, which spins up an in-memory copy of Cockroach that you can use to like showcase features. The really cool thing about Cockroach demo actually is there's a specific flag that you can pass. So if you do -- global, it actually will simulate a multi-region cluster purely locally in memory. And I'm hoping I can show you guys that.
And that's what you're spinning up right now, right?
Yes.
So yeah, and I've done this plenty of times on my laptop. So I could be playing with a cluster at 36,000 feet on my Mac here. And it's kind of cool. And you can start to play with these knobs and dials, like Piyush said. Like you can start to do some of the changes, the altered table commands that allow us to do survivability for regions versus AZs and that sort of thing. I think we've had a bunch of other webinars that do that. So if anybody actually wants to check this out, but when you do start to move data around, hey, Piyush, can you make it? Yeah, there we go, a little bit bigger. When you do start to think through these things and it starts to make sense, it was very important to us to provide the tooling that we're allowing people to actually understand this. In fact, this basically was kind of a troubleshooting tool that we had first, right, Piyush? Like, I think our support team was using this to troubleshoot, correct?
Yeah, exactly. So basically what we found was happening is we would often find customer clusters where they were experiencing some kind of performance degradation, right? And we realized actually like having a tool where each of the nodes in your cluster can ping each other and then just share the latency across each node is extremely useful for multiple reasons, right? One is I can look at this page and I can immediately tell which nodes are close to each other. Now I have my localities already defined, so this is again Cockroach demo, so it does it all for you. So I've got Europe and US East and US West, but just by the color coding of this table, I can at a glance, even if I didn't have those labels, tell which nodes are close to each other. Blue is slow, so I can tell these nodes are close to each other, but they're far from say nodes 7, 8, and 9, right? Versus green is fast. So obviously, nodes 1, 2, and 3 can all talk to each other very quickly because they're in the same region. The reason this is particularly useful is a lot of the times our customers have experienced, intermittent issues or network config problems. It's often a one-way partition that's actually the cause. And this table just makes it like dead simple to identify that as a problem. You can come to this table, and if there's no connection, especially if there's no connection in one direction, what you'll see is just a single column or a single row will be yellow. And that just immediately helps you diagnose, the fact that you have a networking issue, essentially. So this is one of the many tools, obviously, that we provide, but I think this is a particularly useful one because it, both at a glance tells you about the layout, the geographic layout of the cluster, but then two, at a glance, it also tells you if you have any networking configuration problems.
What is in the standard div up top? What is that? What are you trying to communicate there, Piyush?
Yeah, so the idea here is we want to show you kind of like what the typical latencies in your cluster look like, and then plus or minus one or two standard deviations. We like to color code it this way. Originally, actually, it's interesting. This page has gone through a couple of iterations. We actually originally said, hey, really slow latencies are going to be red, but it turns out actually sometimes slow latencies are expected, right? If you have nodes in the US and Australia, again, as an example, you wouldn't expect that latency to be really low. You would expect it to be in the hundreds of milliseconds. That kind of makes sense, right?
Right.
Similarly, Europe, Western Europe to the Western US, it might be 100 milliseconds of latency, right? So we actually changed the color to blue because we're like, well, actually, we just want to communicate that it's different, not necessarily that it's bad. But the idea here is we want to color code this so that you can easily and at a glance see what things are close to each other, physically proximate versus far away.
Yeah, and that makes a whole lot of sense because sometimes you expect it to be very different than something that's very close. And by the way, as a colorblind person, I'm very happy you all chose the difference in color because that red green was killing me as well. So you could just say it was for us as well, right, Piyush? So
we have several
I know
Cockroach mergers, Cockroach Labs employees who are colorblind, and that is actually something we did consider for the design. So you'll notice we used to have red and green in a lot of places to indicate status, and we've gotten rid of it almost everywhere.
Yeah. Well, it's really important to us people. So this is really cool, and I love how this actually calls out the distributed nature of data, and I think that's actually really, really important. I think where it's not as apparent in kind of the distributed nature of data is when we start to think about queries and how we set up our queries. I've talked to a lot of customers about, that distributed mindset, and there's a distributed mindset in the way that we deploy, right? This is kind of deployment, right? But there's a distributed mindset in the way that we think about our queries, or there might be a query that's messed up because of this sort of stuff, right? And so we actually have a bunch of tools that allow us to look into queries as well, Piyush, right? I guess it's right here, right? Statements and
Exactly. So we have a couple of pages. So we have sessions, transactions, and statements. So right now, I don't think there's a workload running against this cluster. So you're probably not going to see much in here as of right now. But basically what these pages do is they let you introspect basically anything that's actively connecting to the cluster. So that's kind of the sessions page. It'll show you all of the open connections and whether they're actively executing a query. So if you have as an operator, right? If I'm an SRE, if I have, and you can see things popping in and out here. If I have, let's say we rolled out a change of our application, and someone perhaps didn't, optimize a query, right? It resulted, they didn't add an index somewhere, and it resulted in a full table scan. What this sessions page actually lets you do is it lets you see long-running sessions, so connections that are held open, queries that take forever to execute, and you can actually just go in and kill them. So I could, for example, go in here and terminate the session. So if I have, let's say part of my application that's issuing this query is really slow and it's hogging resources in the system, I can just come in here and kill that session, and it'll kind of resolve the situation in the cluster.
Hey, Piyush, how long would it take to just get a workload up and running? It's pretty simple to do, right?
Yeah, it's not too bad. Here, let me.
You want to? Would you be bold enough to go on command line and just show starting up a workload? Yeah. I know, like anything can go wrong. There's typos. I mean, dude, but it's actually pretty cool. Like, yeah, well, boy, that's all right.
So let's see if I can do this on the fly.
I appreciate you doing this.
Flag.
Yeah.
So again, the thing to keep in mind is CockroachDemo, super useful tool, and our help text is also generally pretty great. So if I'm at a bit of a loss on what to do, all I have to do is do CockroachDemo -- help, and I can kind of pick out, hey, look, there's this with load flag, which makes it really easy to turn on a workload in this cluster. So what I can do now is use CockroachDemo.
So we have a demo cluster, and we actually package a couple of different workloads here. We have TPCC. We have something called Mover, which is a sample app that we use all the time. I think we have YCSB. We have a couple of them here, right, Piyush? So you're just, I think, what did you choose one?
By default, it's Mover. So
it is, yeah. By default, that's right.
Yep.
But you could change it. But regardless,
yep.
What's nice is that, you can simulate a cluster and simulate load on that cluster as well, which is kind of one of those things I find extremely awesome because, well, it helps me demo, but it helps people play with the database and kind of see what's going on, right? So
yeah, this is a tool that's heavily used by our education team. So in our training examples in Cockroach University, right? This is just an indispensable tool because it lets you essentially, with no you don't have to figure out licensing. We actually spin up a temporary enterprise license for you to try enterprise features. It's valid for an hour. So you don't have to worry about, like getting a license. You don't have to, connect to Cockroach Cloud. You can just grab the Cockroach binary, brew install Cockroach if you're on a Mac, and then do Cockroach demo. And you're ready
super easy. Yeah, and then you're up and running. It just takes a minute or two to get this up and running. But then I think it's also important to understand. We're off the cuff here, everybody. We're off our script a little bit, but the DB console that Piyush was showing as well. I think what's really important here is, and actually it's pretty important deal. And it actually comes back to the how well we work. Like you can connect to the DB console, right, Piyush? And it's basically any one of the nodes will service up the DB console, which is actually pretty important, right? So it isn't like we have a separate node running the console. No, we have basically like we have all nodes. Every node can access all of this information, which is actually pretty cool. So we're back, and I think we have now. You have sessions. There we go, buddy.
Yep. It's just starting up, so it might take a second to populate. But the other pages are also obviously super valuable. So not just sessions, we can also drill into a specific session. So let's say here, if I click into it. Might take a second to load because the cluster's doing a lot of stuff right now. I can actually, on the session details, I can see, okay, is there an active transaction that's running right now? What statements were in that transaction? And it actually links through to transactions and statements. So if I want to, for example, dive into a specific statement, right? I can click View Statement Details. It'll transition me to the statements page and show me way more detailed information about the statement. Right? So I can, look at the fingerprint of the query, right? And I think an important thing to keep in mind here is we're aggregating information across all statements that have this general shape, right? So the literal values are scrubbed out, but then the performance is kind of aggregated. So we might have a couple hundred executions of something that looks like this, and you can kind of see the distribution of how long it took to execute, how many rows are affected, how much contention there was, right? We can see, the actual plan for the statement. We can see, I mentioned some of the execution stats, right? So how much time each phase of execution took, how many rows were affected, how this was, distributed across all the nodes in the cluster.
Cool. So this is
really
very
powerful.
different than like a normal. I mean, this tool would be usually be separate from the database, right? Like this is just basically part and parcel and core to what we're doing. Can you go back to the diagnostics? I thought it was pretty interesting. I mean, it's actually showing I think it was an overview. Sorry, buddy.
The diagnostics I want to touch on too, though.
Yeah, like the statement details, like showing, did it implement, did it use vectorized execution? Did it use distributed? Did it use a cost-based optimizer? I think that's really kind of cool stuff that, it is kind of unique and meaningful in many ways, right? Yeah, so.
The cool thing about diagnostics, since you mentioned it, is this is actually, and I know we're going to talk about OpenTelemetry, so this is kind of related. So, Cockroach being a distributed system, a tool that is in kind of the observability tool set that people frequently use is tracing, right? Distributed tracing. So Cockroach actually implements the OpenTracing standard, and you can use, your trace collection tool of choice, your Jaegers, Zipkins, light steps, whichever you prefer. And you can actually use them to collect and explore traces for individual statements and transactions in Cockroach. And we actually make it easy enough for you to do that via the UI. So what I can do is if I click Activate Diagnostics, what actually happens is now my cluster is waiting for the next statement that executes that matches this fingerprint. So you can imagine, right? Like I saw, hey, there's a statement in here that looks like it's taking really long on average. What I can do is click Activate Diagnostics. The next time that statement comes in, it'll execute a full trace on that statement. So it's like on-demand tracing, right? You don't have to turn on a tracing setting that captures like samples statements. You can literally say, I want this specific statement and grab me the next one that executes. And this is an incredibly powerful tool for debugging. And this collects not just traces, it actually collects a full, we call it a diagnostic bundle. So it contains all the information you could possibly need to troubleshoot the performance of the query. We actually designed this so that we internally could troubleshoot the performance of our customers' queries if they send us all this data, but it's just as useful for our customers. So it has all the schema information, the actual query that was executed, the schema design and layout of the tables that were impacted by this statement, and the full trace, right? So here's a an overview of how this is executed throughout the entire system, what nodes it was executed on. We have log messages attached to the spans that are involved in each of the things that are being executed inside of the cluster to show you what's actually happening. And you can use this to identify things like contention, right? So if you have two statements that are both trying to access, let's say, the same record in a table, right? Cockroaches, it uses an extremely strong form of isolation, serializable isolation. And so we're very strict about how we order and sequence transactions and how we prevent them from conflicting with each other. So when transactions are contending, when they're both trying to access the same underlying data, we actually will, for example, push one transaction while the one before it is completed, right? So, let's say you have some kind of system where, what's a good example, right? I think the canonical example is, if you're Twitter and you have some extremely popular Twitter user, I don't know, I guess the president, right? Let's say President Biden, sends out a tweet. Obviously, tons and tons of people are going to be looking at that tweet. So you might end up in a situation where, that specific record in your database is suddenly extremely hot. Yep. And, all of these transactions are all contending for the same resource. And this will show you that just immediately. You'll be able to say, hey, actually, we were accessing this specific record, and I can see actually this transaction, it took 3 seconds because it spent 2.9 seconds waiting on other transactions that were accessing the same data.
That's really cool. And it sounds very verbose. When you just kind of activated that, do you unactivate it, or is this something does this weigh down the database at all, Piyush?
No, so you can go in and kill it actually, and I can get into kind of some of the more advanced stuff here. So we keep a history of all of the executions that you've run in your cluster, but you can clear them, and you can also do this via our SQL shell. I'd have to find
That's okay.
it.
There we go. Yeah.
So this is, you can see this is now ready. I can download it, and I think. And it saves as a zip file with all this
exactly. Yeah.
I actually don't think we can clear it from here, but you can definitely clear it from the SQL shell. So yeah, this consumes a small amount of storage, but you're able to kind of easily cancel and manipulate.
But it does. I guess the whole point of OpenTracing was that, the whole design of it initially was to say, hey, let's not add overhead here, but let's add the hooks so we can do these sort of things, right? Because I think. And it really goes back to Google, right? Yes. The whole OpenTracing thing came, and I remember, I had conversations with Ben Sigelman about this. He was the CEO of Lightstep, and he was part of OpenTracing at Google, and he was just like, they just struggled so much. They spent so much time trying to troubleshoot that they had to do it. Like it wasn't like they wanted to. It was a necessity, right? And I think in distributed systems, it's just critical to think about. Like if you're building a distributed system, you're going to add any sort of visibility into it, any sort of observability, we're building a database, but if you all are building an app, thinking about and understanding what OpenTracing is and understanding those tools around it, critical, right? Piyush, it took us a while to get to this point, right? And a lot of headache.
Absolutely. Google was way ahead of the curve with Dapper, which is essentially like what all of these different systems are patterned off of, right? So, Jaeger, Zipkin, Lightstep, companies like Uber and Twitter all designed these things patterned after how Google was doing it, essentially. But ultimately, what ended up happening, and I think how important this is I would say showcased best by the fact that it became a CNCF standard, right? Yeah. Like cloud native computing foundation, right? As soon as they say, hey, this is the standard, and that's what they did for OpenTracing. Suddenly it's like, okay, this is the standard that we're all going to kind of converge on. And it also just shows you how important it is for understanding what's happening, in your application when you're running in the cloud, right? Everyone's kind of shifting to run their applications in the cloud. And with that, I think also comes a transition to microservices, which makes it really hard to understand kind of, end-to-end full life cycle. I want to understand what's making, let's say, a page load on my app take a really long time, right? Well, it's being shuttled, this page load gets shuttled across, let's say, 10 different microservices. Well, I don't want to have to go to each of them individually and look for that specific request and try to piece together this whole timeline. I just want a whole timeline that's laid out for me, right?
Yeah. And the standard is super elegant. It's fairly simple to understand. It's a little complex to implement because I think you got to think through what you're going to do, right? But it's pretty elegant and it works. And I think, like I said, like I always try to take the concepts that we learn and we're exposing to, everybody on the call today and say, like, look at how do you actually use this in the context of what you're doing. Okay, if you're a developer, you want to troubleshoot your database, that's great. But you're a developer, you're going to have to troubleshoot your app. So this stuff is actually pretty important. I think it's elegant. And it was also elegant in its API and the way that it works, right? So we basically just natively integrate with a lot of other tools, right? Piyush, what are some of the ones that you kind of see emerging as kind of the state of the, I guess the most popular, like Grafana, probably, right? What else?
Yeah, so I guess this is interesting because it's very relevant to kind of what's happening in the observability space right now, right? So this also touches on the transition from OpenTracing to OpenTelemetry. And I can get to that in just a second, but first I want to answer your question. So I would say that the three pillars of observability that are kind of frequently mentioned in the same breath are tracing, which we just talked about.
Yep.
There's also metrics, and there's logs, right? So when it comes to metrics, we actually have Prometheus endpoints that we expose for every node in your cluster. So you can scrape metrics from every single node in your cluster, aggregate them, and then you can kind of see, exactly what's happening across your cluster in time series metrics. And, Prometheus integrates with everything, so you can get that data into Grafana. And, there's other third-party tools like, Datadog and what are some other ones? Elastic, right? That will integrate with our endpoint. And in fact,
by the way, Prometheus, another CNCF project, of course, right?
Yes, absolutely. Yep. And it's worth mentioning, we actually did work with both Datadog and Elastic to actually build dashboards in their products when they consume data from Cockroach. So they actually have like some kind of native stuff that we use internally in their tools. But so there's metrics, and then there's logging, right? So logging, there isn't really like a logging standard, and I think that's also partly why like OpenTelemetry is interesting to us. There's like formats, right? So JSON formatted logging, sure, that's kind of a standard, but JSON can really be anything. You can set whatever key value pairs you want in JSON. So like really, you're leaving it up to the end user to like define how they want to filter and alert on the logs in Cockroach. Now, I will say in our most recent release, we actually dramatically overhauled how logging works in Cockroach, and I think we made it substantially better. So actually, previously, we mostly used logs internally for troubleshooting. They were not JSON formatted, which many of our customers didn't particularly like. So we took that feedback on board, and we actually created the option to format our logs in JSON and structure them properly for ingestion and tools such as Splunk and all of the different logging tools, right? But more importantly, actually, the super interesting thing we did is we made it way more configurable in terms of what messages Cockroach is sending to which channels, right? So the types of things you might want to log in Cockroach are very different, right? So you might have audit logs, right? So if you have like a strict regulatory or compliance burden on your business, you might need to see, okay, who's touching all the sensitive data in my cluster, right? That's very different from, let's say, operational logs for Cockroach, like who's spinning up nodes and joining them to the cluster. That might be a security risk versus even like performance logs, right? So I want to log all the slow queries in my database that take over a second to execute, right? Like those are all very different things. So what we did in our most recent release is we actually made it completely configurable in terms of where you sent those log messages. So previously you could only write them into files on disk, but now you can actually do either files on disk. You can send them to a network log sync. So we integrate with FluentD, which can ship logs off to any destination over the web. So if you want to send logs from Cockroach into Splunk, it's super easy now. And actually, that's actually what we're doing in Cockroach Cloud to do our internal intrusion detection. For example, we actually ship audit logs from our Cockroach clusters to Splunk, which is where we handle that. So we're dogfooding it ourselves, and then we're making it available to customers as well. So this is something that's available in self-hosted customers today, but we're also working to make it available in Cockroach Cloud. So you'll be able to eventually configure kind of logging and metric integrations in Cockroach Cloud as well. So those are kind of the three pillars that I mentioned when it comes to observability. Now, the reason OpenTelemetry is interesting is because I think it starts getting into kind of common standards that work across multiple vendors and are kind of vendor agnostic, right? So OpenTelemetry is actually yet another CNCF project, and it's really new. I don't remember when it became a CNCF project with Denver?
It was in the last year, I
within
think.
the last year.
Yeah, I think so. Like year and a half. By
Not
the
a
way,
long time.
Fluent D also, by the way. Okay,
Yes.
keep going. Yep. Carry on. Yep.
We are big fans of, you know,
It
open
seems
source.
that things that
CNCF.
matter all become kind of projects. And so
Yes.
it's actually really important stuff. So cool.
Definitely. So OpenTelemetry actually, interestingly enough, is yet again, I think, motivated by Google at the end of the day. So Google had this project OpenCensus, which was, you know, outside of tracing, it was kind of their observability standard for, you know, things like metrics and logs. What OpenTelemetry does is it actually combines OpenTracing and OpenCensus. OpenCensus actually never became a CNCF project. Instead, the CNCF was like, well, let's just combine this with
Right.
OpenTracing and make it OpenTelemetry. So the really exciting thing about OpenTelemetry is it will now also give us kind of vendor agnostic standards for, you know, metrics, logs, and also tracing, right? So we already had that for tracing. We kind of had that for metrics in Prometheus. I think a lot of tools kind of speak that Prometheus format. But now we'll have it for metrics and logs as well. And the really cool thing is now, you know, OpenTelemetry will also, so you know, OpenTelemetry gives you an API, an SDK, right? So Cockroach is written in Go. They have a Go SDK for, you know, all of the instrumentation that we'll need to do in a product. But now, instead of just having traces with spans that have maybe some logs for contacts, we'll also be able to collect metrics, which is super interesting, right? And that's particularly important in Cockroach because you might have other things that are happening in cluster that might impact performance, right? So let's say I execute, you know, a trace of a statement. The reason it might be slow is because one of the nodes where it was collecting data had another query that was running on it that was making that node particularly hot and was consuming all of the CPU and memory on that node. And that wasn't the query that I was tracing, but of course it's going to have an impact on the performance of the query that I was tracing, right? It's like now we'll start to be able to tie those types of things together, which is super interesting. Like, oh, I can see actually there's a CPU spike when, you know, this span was running on this node over here, right? So like those are the kinds of things that are super interesting to us. And I think also separately, the standardization of formats and vendor agnostic kind of way of pushing things will also help us, right? So we have tons of customers. They use tons of monitoring solutions, right? I mentioned, you know, Datadog, Elastic. There's a million of them, right? And when it comes to logs, it's even more varied, right? So the nice thing about OpenTelemetry is actually it lets you configure essentially, I forget what the exact name for it is, but it lets you essentially, you know, configure whatever sync you would like for, you know, any of these three pillars, right? So, hey, I can send my traces to Jaeger, Zipkin, et cetera. I can send my metrics to, you know, Prometheus or whatever other time series database I might want to use, Prometheus, Grafana, even, I don't know, timescale, something like that, right? And then the logging, I'll be able to configure to go to whatever logging tool I want. The nice thing is, like, you know, we don't have to build those integrations. Actually, it'll be completely, you know, plug and play with what OpenTelemetry is providing us out of the box. You know, assuming, again, you know, it's in beta right now, but I'm predicting that the future of our industry will be kind of converging on that as a standard.
And the community is rallying around kind of the core kind of telemetry that you want to actually pull off. I think all the basic stuff is in place, correct, Piyush? And I think like the conversation is around what else would people actually want to have in here? I think that the core of it's done at this point, right? I mean, within that community. Yeah.
Yeah. I think there are some interesting conversations still happening, and, you know, like OpenTelemetry is definitely still in beta. So I'm curious to see kind of like where some of the decisions end up. But I think you're right. Like a lot of the core pieces, I think, are pretty well understood, right?
And it was pretty easy for us to actually go down that path. I mean, there's a trace in the execution of something, and then there's the true telemetry around it, which is actually, that's the difference between the two. It's trace and telemetry, which I think is that's the concept I see the future of this. I mean, geez, we built huge, massive companies off of, you know, unstructured log files. I remember the first time I saw Splunk, I was like, oh, that makes sense. That's cool. You know what I mean? Like, yeah, somebody took their scripting tool and made a tool out of that, you know, and like, oh my gosh, wow, right? You know,
yeah.
I mean, I was in this space a little bit, and, you know, I worked at this company called Overops, and like our whole statement actually at trade shows was log files suck, which actually is pretty good, right?
Yeah.
I mean, come on, right? thinking about this in a different way, thinking about it, playing JSON to it, making it configurable, where it needs to go to, I think that's thinking about it in terms of like, what's the true power of this stuff? Because I think in distributed systems, it just gets way too complex. Yeah. So.
Yeah, absolutely. I think, the next step, so I would say like, obviously this makes a ton of sense. And I think the eye for this stuff is always more towards like, application developers, not necessarily like our use case, which is very specific to us, right? So I think, for us, the focus also has to be, how can we make this as simple to understand as possible, right? So when you're running a distributed trace for an application, you built, right? You understand what all those microservices do.
That's
if you're
right.
running a distributed trace inside of Cockroach, like how much do you understand, what are, I don't know, like we have so many complex systems under the hood, right? And you don't need to understand all of those things to be able to use Cockroach effectively. In fact, you shouldn't have to understand all those things. That's part of the magic of Cockroach. So like an extra challenge, an extra wrinkle for us is, okay, how do we make this comprehensible for someone who isn't, like a PhD in Cockroach, right? That's where.
And think about what it's meant for onboarding of new engineers on our team as well. And so like, again, a core learning here at Cockroach that I think is applicable in other ways and the way that we do these things, like thinking through how we structure, what these things are named. This is all actually really, really important for your own productivity in your team. And I think we grew as a team, our engineering team is growing, tremendously right now. I think we just, we've got another handful or two this week, Piyush. So, which is great. And by the way, if anybody's out there, they're looking, we always hire, right? But like I said, like these are the concepts that I think are the most important. So there were a couple questions in here, Piyush. I want to just get to those before we sign off. But is there any documentation on how to use Jaeger with CockroachDB?
Absolutely. So we have documentation. So the diagnostics bundle that I actually just showed you, there's really quite good documentation on that on our doc site. And the nice thing is the trace file that it generates, you can actually load into Jaeger.
Yeah.
So it actually generates a format that's compatible with Jaeger. So you can just load it into Jaeger that way. So we do have that on our doc site. And let me try to find.
Yeah, I was going to say, I was just going to do the quick search. Our docs are, while you're just typing that, Piyush, that's great. Our docs are pretty verbose on pretty much everything. I would be remiss if I don't call out our docs team. I do that, I think, every time I'm on any sort of live event. I think our docs do a phenomenal job. They're free, they're great, they're searchable. You can typically find what you want to find. And the step-by-step is great. Led by Jesse and team, I think they do a great job. So these things actually do make a difference because, it's kind of different. Yeah. So there's the visualizing statements and traces in Jaeger. There's the link there for Bruno. So thanks for asking. There was another question early on from Beverly asking, how often do you monitor network parameters, i.e. the latency stuff? Piyush, do you monitor this only when nodes are communicating data, or do you periodically ping them? Like what's kind of happens?
Yeah, it's actually.
I think it's both internally what we're actually testing, and then there's like maybe the troubleshooting side of it. This is definitely the internal. How often are we doing it, right?
For sure. Yeah, the actual tool itself, right? Like that network latency page, I believe is essentially pinging every node in the cluster. I think every like 10 seconds or so. So that page will update every 10 seconds. Yeah. So it's not just like when nodes need to communicate to exchange data or you're executing a query. It's actually just continuously in the background. There's not a lot of overhead to that.
And then people monitoring them, and this is just one of those things you use once you feel there's an issue, like you see slowdown, or you see like so maybe your P99 latency has gone up to doubled or tripled. You start troubleshooting. That's one of the places you look, right?
Yep. Yeah, exactly. I don't think network latency in and of itself is necessarily something you would monitor, but obviously you're going to have, like you said, right? Alerts configured for latencies for statements or other performance characteristics of your database. And once one of those alerts goes off, you can come into the DB console, and that will be one of the places that you'll want to check for sure.
That's right. What can go wrong will. Right. So.
Definitely.
Anything else that we missed, Piyush? I know we talked through a couple of things. I think we hit everything, right, that we wanted to hit on.
I mean, I could talk about this stuff forever. So
I know. I'm aware. But I think we hit all the highlights within the product. And I mean, as with anything, we're happy to talk about or drill down into any of them. I think both of us are happy to take questions, both during this and post. Our community Slack channel, we have a whole range of people happy to talk through these things as well. But I don't think there's any more questions. So Piyush, thank you. That was great. It was a good quick overview of what we're doing here. I hope it was helpful for everybody. Do you have fun, buddy? I know you love talking about this stuff.
It was great.
We do an hour and a half next time. You could talk,
for sure. Like some of the cool stuff that we have coming. Oh my gosh! Like I'm excited to demo it someday. Like one thing that Tommy, one of our PMs, is working on right now is what we're calling like the hot ranges stream. So Cockroach, again, is sharding all of your data underneath the hood, right? And it's creating replicas of those shards and distributing them. We call those shards ranges. And so if you put a lot of load on a single range, you probably want to know that because, again, right, like a single leaseholder is coordinating that. So you might create a hotspot in your cluster somewhere. So we're exploring some like really cool visualizations to help you understand, as a user, understand, oh, like my cluster is experiencing a hotspot in this specific space. So maybe next time we'll have some cool visualizations we can show up.
I love that because it shows off one of these core kind of really cool things about Cockroach. One of the cool things about when there is a hot range, Cockroach will try to isolate that on a server that is less utilized than the other servers so that it can optimize performance, which I think is just awesome. Like
there's more to it than that, actually. It even we do load-based splitting. So for example, if this range has multiple keys that are hot, what we'll do is we'll split it into smaller shards, right? Smaller ranges, and then distribute those ranges into different nodes in your cluster to try to spread out the load automatically.
It's just,
I can talk about this stuff forever. Like it's so much. There's so much to it.
Come on, software engineers, knock it off. That is actually, it's one of those concepts that's lost, I think, in way deep in the details, but architecturally really, really important. And again, I like to call out the principles in Cockroach that are actually applicable in some of the things that we all do. Like if there's a service, a microservice you're working on, it's just too big, too bulky, break it down and eliminate those bottlenecks in what we're doing, because I think that's the tricky part about distributed systems, the physical nature, where these things are executing, how many do you have running. We deal with it day to day in a database. We automate a lot of this inside the system because the data actually dictates kind of how these things are actually running. So it's really cool stuff. So, well, cool. Thank you, Piyush, for doing this today. I really, really appreciate it. I hope it was valuable to everybody. And a recording definitely will be available, I think within the next hour or two, whatever it is. We're pretty quick. JP gets it up on our YouTube channel pretty quickly. There will be a survey after this as well. We'd love to know how well this went and if it was useful or not. Please do take that. We take these things seriously. This is a series of stuff that we're doing around features in our product. Hopefully we make it valuable for other things, but definitely about kind of what we're doing. So if you have any interest in talking to us, feel free to reach out to either Piyush or Jim. We're both, you're definitely Piyush at Cockroach Labs, right, Piyush?
Yes.
Oh God, yes. I can't imagine that you weren't the first one. And I'm definitely just Jim at Cockroach Labs, but thank you everybody for attending. Thank you, Piyush.
Thank you, Jim.
Yeah, you bet, buddy. And everybody.